In this lesson, we will solve a system of inequalities, sometimes linear, sometimes not. Notice these will now be inequalities, and we are going to solve by graphing as we did before. So this is a linear system of inequalities. So 3x plus y is greater than or equal to -3. The first thing I'm going to do is I'm not going to worry about shading until I get to the end, but I'm going to plot the points that would make up the line. And when I do that, remember, I don't think of it as an inequality. I think of it as an equation. So I would think about it as this equation, which I could then turn into y equals -3x minus 3. So it would go through here at -3. My slope is -3, so that's down 3 over 1, or up 3 to the left 1, as many times as I need to. And again, when I connect the dots, pay attention to dotted or solid line. This would be a solid line because it's or equal to. So that's my first one. And I'm not even going to be concerned yet about which way to shade that one. Then I'm going to do the same thing here. So again, this is x plus 2y equals 4 is the line that I'm going to graph. If I want to turn it into slope-intercept form, I can, or I can use that cover-up trick. I'm going to use the cover-up trick to find that x should go through the x at 4 and the y at 2. And again, I'm going to connect the dots, this time with the dotted line instead of a solid line. So now I have my two lines, but I'm graphing a system of inequalities, which means that I need to have some shading. So as we can see, there are actually 4 different regions here. 1, 2, 3, 4. And what I'm trying to do is find which of those 4 regions would be shaded for both of these equations. So let's look first at the 3x plus y is greater than or equal to 3. That's that solid line right here that I graphed. Choose a test point. I bet you can guess what I'm going to choose. 0, 0. And if I choose 0, 0, I have 3 times 0 plus 0 is greater than or equal to -3. So 0 is greater than or equal to -3, which of course is true. So what that tells me is that the solid line should be shaded towards 0, 0, which means 2 and 3 are shaded for this solid line. Now I'm going to do the same thing with my dotted line. So I'm going to choose 0, 0 again because my line doesn't go through 0, 0. And that gives me 0 plus 0 is less than 4, or 0 is less than 4, which of course is false, which means the dotted line should not be shaded below, but should be shaded above. Now, a solution to a system of inequalities is where would both be shaded. So which of those zones would be shaded for both of these equations? Well, it looks like zone 2 has been shaded with both the blue lines and the black lines. So my region here would be this dotted line, this solid line, and then all of this business in here onto infinity. So that's the graph of the solution set. In addition, I'm interested in the intersection point, which will make sense in about 2 videos when we actually use that point. But it looks right now that it goes through at -2, 3. If you're not sure, if you have a point, you can of course plug it in. I could plug in -2, 3 and check it. But of course, sometimes this is going to be more difficult. So instead of taking the easy way, I'm going to show you the real way, which of course is to solve the system of equations, which means, you know, use substitution or elimination to solve. And hopefully I get the point -2, 3 or something really close to that. And if I don't, I've done something wrong. So again, I'm going to take these equations and I'm going to use them as equations, not as inequalities. I'm going to take this first one and I'm just going to use substitution. So I'm going to take x plus 2y, and instead of y, I'm plugging in all of the stuff that y is equal to. That gives me x plus -6x minus 6 equals 4. That gives me -5x equals 10, and x is -2. So I'm feeling pretty good about my point -2, 3. Take that -2, plug it back into any of those. I'm going to choose this one. negative 3 times x minus 3, which gives me positive 6 minus 3, which gives me 3. So my intersection point is negative 2, 3. Negative 2, 3. Now again, this one I actually did all of the work to find negative 2, 3. Normally I would look at this and say, yeah, that looks pretty good, and I would check it by plugging it into both of those equations. But if you're not sure, this is how you would do that. Here's one for you to try, and for the sake of time moving forward, we're not going to find the intersection points until we actually have to use them. Otherwise, this will be a 30-minute video and you'll want to cry. So go ahead and try this question. Just graph the solution set. Don't worry about finding the intersection points. We'll worry about that later. So again, the first one here is going to be a quadratic equation, which means it's a parabola when I graph it. I'm going to rewrite that as y equals negative x squared plus 4. This obviously a quadratic. To graph a quadratic, I generally find the vertex, which means I'm doing the opposite of b over 2a and then plugging that value into the function. B in this case is 0, so 0 over 2 times negative 1 would just be 0. So my vertex is at 0 comma something. The something can be found by plugging in 0, so 0 squared, which is 0, negative 0, still 0, plus 4. So 0 comma 4 is my first point. From here, I know that it's going to be pointing downward because of that negative, so I know it's going to look something like this. Easiest thing to do is just start plugging in values. So plug in 1. 1 squared is 1. Take it times the negative, so negative 1 plus 4 is 3, so 1, 3. Using that axis of symmetry, which goes through right here, I would then put a point on the opposite side of that. Plugging in 2, 2 squared is 4, make it negative, so negative 4 plus 4 is 0. So I've got a point here and then reflected a point right over here. This is obviously a solid line, so it's going to look like this. And again, I'm not going to worry about shading until I've also graphed the other function. The other function is just a simple absolute value function. The absolute value function, because it's not being transformed, there's no plus or minus inside or outside, goes through at 0, 0. Again, if you're unclear what it's going to look like, just plug in a point. Plug in 2. The absolute value of 2 is 2, so 2 comma 2, 4 comma 4, etc. If I plug in negative 2, I still get 2. If I plug in negative 4, I still get positive 4. It's an absolute value function. This is also a solid line. Solid because of the or equal to on the inequality. Now I've got either this region here, all of the stuff to the left of the parabola, all of the stuff to the right of the parabola. I've got this region here in the middle, and I've got this region here. So really I have 5 choices. Again, use 0, 0 as a test point if you can, and I can for this first one. I would get 0 is less than or equal to 4 minus 0 squared, or 0 is less than or equal to 4. 0 is in fact less than 4, which is true, so that automatically took off 1, 3, and 2. So it's either zone 4 or zone 5 that it's going to be shaded, because all of this would be shaded for this first one. For the second one, obviously I can't use 0, 0 because 0, 0 is a point on my graph. So choose another point, either a point up here in zone 4 or a point down here in zone 5 to help us to know if it's inside the V or outside of the V. I'm going to choose the test point 0, 2, which is right here. So 0, 2 means 2 for y, 0 for x. That gives me 2 is greater than or equal to 0, which is, of course, true. 2 is greater than 0, which means it should be shaded inside the V, which means now it's all of this stuff. Now, in terms of finding those intersection points, again, we're not going to do that for now. We'll wait till later, but all I would do is then solve this system using substitution. So I would set replacing y with positive x, I would get x equals 4 minus x squared, and I would solve that. And then, of course, I would replace y with negative x. We do that because of the absolute value, equals 4 minus x squared, and solve that. That would give me the x values here, and then I would plug them back in to find the y values. We won't do that for the sake of time. Here's a fairly easy one for us. So if you kind of struggled through the last one, maybe use this one as your practice on your own question. If I were to graph this, again, I'm going to graph it as quickly as I can for the sake of time. These are both in standard form. Standard form means if I can, I'll use my cover-up trick. So if I cover up 3x, I get y is -3. If I cover up y, I get 3x is -3, so x is -1. I've got a nice solid line connecting the dots there. Again, if it's better for you, turn it into slope-intercept form. For this one, I would cover up x, I would get y is 2. I would cover up 2y, I would get x is 4. I would connect the dots with a dotted line. You should use a ruler. I obviously don't have that luxury since I'm writing on the computer screen. To find out which way to shade, 0, 0 seems like a good test point to use. So if I plug in 0, 0 here, I get 0 is greater than or equal to -3, which is false. So again, if I had this, and you don't have to number them, but some people like to be super organized. So this one tells me that 0 is greater than or equal to -3, which is false, which means the solid line should not be shaded towards 0, 0. So it's either 1 or 4 we're looking at. So 1 or 4. Looking at x plus 2y is less than 4. If I plug in 0, 0 there, I get 0 is less than 4. That one is true. So true tells me that this dotted line should be shaded towards 0, 0, which means 3 or 4, which means the only one that works for both is 4. So the region that should be shaded is right here. So not a bad idea to use that little numbering system if you want. It's a little less crowded than making the different lines of different colors. Here's one for you to try on your own. This one obviously is going to be a little bit more complicated, so press pause and really take your time on this one. For the first, this is a circle, and it goes through at 0, 0 with a radius of 5. So 0, 0, radius of 5, dotted or solid line. We look at this, which means solid line. Not too shabby of a circle. This one is linear. Notice x to the first, y to the first. So I'm going to probably just rewrite this as y is less than x plus 1 by adding x to each side. So I would start at +1, use my slope of 1 to go up 1 over 1, up 1 over 1, etc. I would connect those dots with a dotted line, dotted or dashed. And then my last one, y is greater than or equal to -4. That's just one variable. So one variable means it looks like this or it looks like this. So I go to where y is -4. And this one's going to be a solid line. It's going to look like that. So I've got a lot of different regions that could be shaded right now. So let's, if you want to use the numbering system, let's do that. I've got zone 1, which is all this out here. Zone 2. Zone 3, tiny little zone 4. I've got a zone 5 over here. I've got a zone 6 down here. I've got a zone 7 over here. All sorts of fun. Now, just take it systematically, just a step at a time is the best way to do it. So it looks like, lucky for me, I get to use 0, 0 as my test point in all of these. So if I plug in 0, 0 into the circle, I get 0 is less than or equal to 25, which of course is true, which means the circle should be shaded in, which means it has to be 2, 3, or 4. Those are my only options. All the stuff on the outside of the circle doesn't matter, it can't be shaded. Now let's see what happens for this one. If I use 0, 0 as a test point, I get 0 is less than 0 plus 1, so 0 is less than 1. Still true. So with the dotted line, should be shaded towards 0, 0, so 2 is out, so it's just 3 or 4. So again, I didn't say 5, I didn't say 6, because I knew those were already out. So I've got this down to either 3 or 4. To decide, we'll use, of course, our last one, so use 0, 0. 0 is greater than or equal to -4. True or false? 0 actually is greater than -4, so that's true. So from this line, it should be shaded towards 0, 0. So between 3 and 4, it must be 3. So zone 3 is this region in here, and that is the one that is shaded. For this last example, we're going to actually solve an application of a system of inequalities. So this is leading us up to linear programming, which is coming up in a couple of videos, but this is a good start to that. So Jeremy has 20 hours a week available for exercise. Let X represent the number of hours he spends running and Y the number he spends weightlifting. So X and Y, they've already told us what they represent. We're going to set up an inequality that shows the number of hours Jeremy spends running. And of course, we know that it cannot be negative. So X has to be greater than or equal to 0. For weightlifting, it can't be negative, so Y has to be greater than or equal to 0. And a lot of people say, well, we know these only has 10 hours, so shouldn't I say X is less than or equal to 10? I'm going to do that in part C because together, combined for the two, it cannot be more than 10. So X plus Y together has to be less than or equal to 10. So that's when we use that 10. We're going to set up an inequality that shows Jeremy will spend at least twice as much time weightlifting as he does running. So at least is going to be a key word there. Twice as much time weightlifting, which means I would have to take 2 times the number of hours running in order for it to be equal to weightlifting. The inequality says at least twice as much time weightlifting. So that would be greater than, Y would be greater than or equal to 2X. So even if I doubled running, sometimes Y is still going to be greater. If it makes you feel better, write that as Y is greater than or equal to 2X. Weightlifting is at least greater than or equal to twice the amount of time running. Those are considered constraints. Again, we'll use this terminology later when we're actually solving with linear programming, but these would be considered constraints. Pay attention to these two especially. These are the easy ones, but a lot of people forget them. Now, here are the same equations I just came up with on the other page. And now I'm going to graph these, and this one we actually will find the points of intersection together. So X is greater than or equal to 0 means that here is where X is 0. Remember, X-axis and X equals. This one's going to be this line. Y is greater than or equal to 0 is this line. We're going to worry about the inequality part in a little bit, but right now I've got 4 zones that could be shaded. This one, if I graphed it, again, I would probably use the cover-up trick, which would put a point here at 10 and a point here at 10 and connect the dots with a nice solid line. So now I'm looking at one of 2 zones that can be shaded. Oh, just kidding. Let the cat out of the bag on that one. One of 5 zones right now that could be shaded. And then, of course, this one would be going through at 0, slope of up 2 over 1, etc. And that's what that graph would look like. So now I've got several zones that could be shaded. Now, I know right away that these two are saying X is positive, Y is positive. X is greater than 0, Y is greater than 0. That's why I said for sure it's not here, it's not here, it's not here. So I'm not worried about any of these. So I'm really focused on this part. So what would be shaded here? I know that X plus Y is less than or equal to 10. If I plugged in 0, 0, I would get 0 is less than or equal to 10. True or false? That one's true. So that means it's either, let's go ahead and give these some numbers. It's either 1 or 2 because this line should be shaded towards 0, 0. So this is 1 or 2. We're not sure which. This one, I can't use 0, 0 as a test point because it goes through 0, 0. So let's choose a point that would be easy to check, like 0, 5. So if I plugged in 0, 5, I would get 5 is greater than or equal to 0, which is true. So this line should be shaded towards this, which means it must be zone 1. Here is my shaded region. Now, what I want to know now are what are the points of intersection, because that's going to be important to us later. This one's real easy, and so is this one. So I know the point 0, 0 is a point of intersection because it connected this line and this line and this line. So 0, 0. This one up here is very easy. That's 0, 10. But this is a triangle, and there's a point out here, and I don't know what that point is. So how do I find it? With 4 equations. I find the 2 that actually cross here, which are these two, and then I solve using substitution or elimination. So I would take, in this case, just for clarity, I will rewrite. I have x plus y equals 10, and I have y equals 2x. I'm going to use substitution method. So I'm going to plug 2x in for y, so x plus 2x equals 10. So 3x equals 10. And x is now 10/3. To find y, I would plug it back into either equation. So I'm going to say y is equal to 2 times 10/3, which means y is equal to 20/3. So what are the coordinates of that point? 10/3, comma 20/3. These are my 3 corner points. We'll talk about why we use them later, but it's important to know how to find them.